Hello, welcome to CST 351 Introduction to Data Science. Today's topic is on data preprocessing, also known as data wrangling. This topic in data science has two parts in our course. The first part, I will talk about data preprocessing, how to read the file, how to do some manipulation. And the second video also will be a continuation of the preprocessing and also a brief introduction to visualization. I apologize up front because I have some allergy and I may cough during this video, but I try to cut them out of the video, but sometimes they may skip from my editing. Whatever techniques you want to apply for data analysis, before that, one on the pipeline of a data science problem, what we need to do is data pre-processing or data preparation. So the data usually we collect from some measurements, they're not clean, they're not structured. Also, we don't have a good idea about this data. We don't know if there are some missing value in data. We don't know if we want to do comparison this data or properly normalized. And also, we don't have any visualization conception of this data. So data pre-processing is a collection of all these methods which we prepare the data and make it ready to fit it to an algorithm whose output is a prediction or a comparison or finding a statistical significance about the population. But this part, the data pre-processing is in all type of data science problems. So data pre-processing has 5 steps. The first step is to read the file. So usually the data are collected in a raw format in a file. Sometimes they're not very structured. We need to make them structured. And what we wanted to have at the output of our file is a two-dimensional array. For this two-dimensional array, usually the rows represent the samples and the column represent features. So as I said, in data science, we mainly study a sample set from a population, and each sample has some attributes. So if you want to put all this info together, you have a two-dimensional array. So the goal is to read this data into a two-dimensional array. Some things look like an Excel file. In Excel file, we are always dealing with two-dimensional array. We have row and columns. So reading this file in structured format, for instance, if they are in JSON format, we want to pre-process them and put them in a matrix form, because most of the machine learning algorithms and then also statistical pattern recognition techniques get the data as a matrix. And this matrix is basically samples, and for each sample we have some attributes. The next one is whenever we are reading the data, our measurements are usually not complete. Sometimes in order to measure some attribute about some samples, we don't have access to some particular features for particular samples. So, and because data are valuable, we don't want to cut out those samples if we cannot measure some attributes. So the way is we keep the data but for some attributes, we just leave them as blank or non-available value. We usually use the term NaN. That means the measurements for these attributes were not available when we are collecting the data. The reason is it doesn't matter. So we are dealing how to address the issue of missing values. So because if you have a very structured file and then pass it to a machine learning algorithm, that you may through error, so because some entry in that the matrix are missing or blank. We wanted to see how we address this missing value. The third step is outliers. So we wanted to take care of the outliers. So outliers, when we are studying a population, we have a sample from this population. Well, we assume that this population has a probability distribution. So an outlier is a sample which is very unlikely drawn from this distribution. This is called an outlier, and we will show how to specify outliers in our data and how to take care of them. And the next step is normalization. As I said, we may collected our data from different setups, different times, different labs. They might have some sort of bias or setup. So we need to normalize data in order to make the comparison fair. However, normalization is not recommended for all problems. It depends on our problem. We should do the normalization or not. And at the end, when we have the data, now data are in a very nice format, and then we already took care of missing value, we get rid of the outliers, and when you normalize the data are ready to be fed to our method or algorithm. But before that, we can still get some insight about data by visualizing our data. So visualization method usually are used at the end of the data science problem by which we want to evaluate our system. But sometimes before we even do the analysis, it's better to have some visualization, having a scatter plot of data to see how the data look like, or when we take care of the missing value or outliers. By visualizing, we can also see if this data don't contain any missing value or any outliers. So these are 5 steps that usually we take when we wanted to prepare the data in a data science problem. So I'm gonna go through each of these methods. So for today, I'll talk about the first 2 topics, and then the next video we will talk about the founding outliers and dealing with them, and also normalization and possible visualization techniques. So reading the file in Pandas. So the standard library which we use throughout this course, and also it is now standard library in most of the data science problem, is the Pandas libraries. So if you study the book Doing Data Science Using Python, which I uploaded on Blackboard, that has a very complete section on how to reading and handling data file using Pandas. The most important thing is when you're reading a data frame in Pandas, data frame read this file in, when you are reading a file, the Pandas reads this file into a data frame. So you should read and study about the structure of a data frame, what is a data frame, and all types of operation you can do on a data frame. So if you haven't seen my slides on introduction to Pandas, I would recommend go to and upload that Jupyter Notebook file and run those cells to get familiar with the different operation in Pandas and in particular data frame. So data frame basically is a 2-dimensional array. It's a data structure in Pandas, and the most important thing about the data frame is it comes with a number of methods. So data frame is basically an object, and this object has a number of methods, and with these methods you can do lots of operation on your data. So later on I will show you some summary of these operation we can use on data frame. Okay, so there are a number of functions we can use from Pandas to read the file. The one I recommend is read CSV. So this is a very comprehensive function to read the file with lots of options, and then you can do a lot and manipulate the data. You can say which file column you wanted to read, which rows you wanted to read, how to treat the missing value, and a wide variety of options in this reading CSV file. And then also don't confuse by the name of CSV. You can read a tab delimited file or other type of separators file using read CSV. So we are using this one throughout this course, and also sometimes we have Excel files you can use read Excel. As you see, there for different data structure, there are different functions. If you have a JSON file, you can use read JSON, but our focus is on read CSV. So from now on, we are reading some files, so you need to have access to these files. I have uploaded all these files, or as we proceed, into a file called data into the document on Blackboard. So you need to download these files and then place them somewhere in your computer, and then have a proper link to those files in order to run these cells. So if you don't have the proper link, then when you run these cells, you will get an error. And also, I forgot to mention, I have a PDF version of Jupyter Notebook. The Jupyter Notebook files are uploaded on Blackboard, so you can download the Jupyter Notebook format and then run them on your computer. And here I only have a PDF file, so I'm not able to run them. When you wanted to read a file, you need we use the pandas library. So in this library, we first import a pandas as PD. It's an abbreviation which is now standard. And then that's the library we use. The others are some other auxiliary libraries we need when we wanted to read a file. And also the data set I have used in here is from this website, this resource. These are some monthly total international airline passengers in early days, 1949 to 1960. So reading a file using read CSV is very simple. So this is, I call from this library this function, and then I path the link. So know that you have to change this link in your computer to link it to your file. So when you read this file is now stored in a data frame. So data in here is a pandas data frame. So pandas data frame are a special data structure, and they are basically an object, and they come with a numerous number of functions. You can apply functions on data frame, but simply they are like an Excel file. Excel file with two columns, with a row and column. And if you don't tell how read CSV read your file, you will treat the first row as the label for your columns. So that's important. If the first row is data is not the label column, you should tell the read CSV that the first column it should be treated as data. Otherwise, it will be column labels. In here, in this file, the first row indeed are the column labels, and then also we have the rows labels. If you don't specify, it would be some numbers from 0 to n-1, where n is the number of rows in your original data. So the function head in here is a function when you wanted to take a look at your data. If you have a big file, you don't want to print out all file into the screen. So head basically tells you, if you don't put any argument, you'll print out 5 rows of data. If you specify a number in here, then it will print out the, for instance, in here I said 10 rows. It will print out 10 rows of these data. So this is a very handy function. When you're reading a file, I will recommend to first take a look at the rows, first few rows to get a sense how the data look like. Have you read the data correctly? What are the columns name? So that's a very handy function we usually use. Also, if you wanted to get some comprehensive info about the read CSV, so if you use this question mark before that function in Jupyter Notebook and then run this cell, that will print out the help information about this function. Okay, so that's enough for reading. So throughout this course, or for many real application, data science application for files, we use read CSV for reading files. Okay, so when you're reading the files, because these data are collected from some measurements from a real world problem, in many cases we don't have the entire measurement. Some measurements are missing. Usually we have two types of missing data or missing values in our data. The one is that completely at random for some problems which we have no idea, some part of data are missing, which is random. We cannot find a pattern. So if you consider a two-dimensional array like a matrix, the missing value is scattered all over the matrix without any particular pattern. Another type is the missing values are not at random, but they follow a reason. So sometimes due to some limitation in experiments, we were not able to complete our measurements. But we also don't want to throw out those samples for which we couldn't measure some attributes. So note that in data science, data are very valuable, and some measurements are we cannot, they're costly and they're expensive, time consuming. So in particular for some medical applications. So we want to keep the data as much as we can. So if you don't have measurements for some attributes, we still want to keep the data, don't throw out the data. So, but by looking at our data, we see a pattern. So for instance, if you consider a matrix, we see, on lower left bottom corner of that data set, if you have a heat map, the data are missing. So these are two types of missing values, and then we will show you how to treat them. There are basically two methods to deal with the missing value. The first one is dropout, and second one is imputation. So dropout is simply says if you have some missing value, you just ignore that sample. So it's very important when we are talking about missing value. Should we drop the column or row? So let's say I have a matrix, okay, and then I have one missing value in here. So this value, let's say, is missing. So when we say dropout says, okay, drop that sample. So if we can drop this we can drop this row or this column where we have this missing value in here. Okay? So it depends on application. It depends how data are presented. So we cannot have a strict rule, drop the row, drop the column. Okay? So depends on application by application, we may decide to drop the row or drop the column. But the norm is, if this is the row represents samples, and then we can drop the entire row. Sometimes we wanted to drop the entire column. So for instance, if I have lots of missing value in this column, so let's say 3 out of 4 values in this column are missing, then I drop this column. So you can tell the function to drop row or column for missing values. So, but when should we use dropout? So when the number of missing values are insignificant compared to the total number of entries for our data, we can do a dropout. Let's say, give you an example. Let's say we have collected 100,000 samples with different number of measurements. If you find out that only like 50 samples, for 50 samples we have missing value, so it's recommended to ignore that 50 samples, because 50 compared to 100,000 is a small number. But if you have, let's say, 1,000 samples and then 100 are missing, then we don't recommend to remove all 100 rows. As I said, data are valuable. We wanted to keep as much as information in our data. So this is where we use dropout. Imputation is another technique which tells you, okay, you have the data now, based on some idea about this data, we can replace the missing value or NaN value by some numbers. The first method is expert guessing. So basically we go and talk to an expert. We say, okay, these values are missing. What do you think we should replace this value based on your knowledge, based on your prior knowledge about this data? But usually it's not recommended. The reason that we are dealing with big data. And in big data, if you wanted to get an expert knowledge, it will be very time-consuming process. The very popular comment is called averaging. So averaging is simply we replace the NaN value by the average of a column or row where this missing value lay, right? So a simple example, let's say if I have a column 5, whose value are 5, 10, this is NaN value, and 2 and 20, then I can replace this NaN value by the average, so average of the other value, 5 plus 10 plus 2 plus 20 divided by 4. So this is how I replace the NaN value, by average. So you can also use other statistics. We can use median instead of mean. So it depends on how you see your data. The reason is, as I said, we assume that these data are coming from a distribution. When we don't have a value, the best guess for this value is a mean, right? This is very high likely this sample is from the mean, whereas if your sample is from 2 tails, this is very unlikely. So this method has its own also pros and cons. For instance, if you have, let's say if you consider the Gaussian distribution, let's say if your real missing value is in here, but you replace it with mean, so that's a huge difference between the actual value and replaced value. But this is how we can consider based on probability that this data is coming from a mean. So averaging is the most popular technique, in particular using mean, replace the mean. Again, replacing the mean of the column and row, it depends on how your data are structured. So if the data are structured such that a column represents a future, it's better to replace that missing value by the mean of the column, or how much the data are missing. So this is just imputation, or dealing with missing value using averaging or replacing by mean. There are also 2 other techniques. They're more advanced. One is using regression, another one using expectation maximization. The first one try to feed a regression line and then to predict the missing value. The other one use a probabilistic approach that we have some visible and invisible data. Invisible data are missing value, and we try to probabilistically find the expected value of the missing value using a technique called expectation maximization. These 2 techniques are out of scope of this course, and barely we use them but we recommend to use averaging. Okay, so if you want to see how we can do the dropout, drop missing value, the function we are using in pandas is called drop NA. So each data frame has a method called drop NA, and drop NA basically drop the NaN value. And this function comes with lots of options. So you can specify if you wanted to drop the column, if you want to drop the row. So for instance, if I wanted to drop the rows, I set the axis to 0. You can say if you find any, if you only find one missing value, drop that row completely. You set any. If you wanted to set a threshold, say if there are like the nth number of missing value in that row, you can use the threshold. Or you can set a predefined subset and then you have the option of in place. So in place, pay attention to this in place. When you do the in place, the drop non-available value function method apply to this data frame and then replace all missing value by the setup you specify. And new data frame, the data frame just is free from missing value. But if you want to have the original data frame, you should set this one to false. That means you keep the original data frame and then you pass this data frame to new data frame. So I can say, let's say new data frame is A equals to this, in place also is false, then the A contains the missing value replaced. Here there are two other functions. These are two other methods for data frame, describe and head. Head I already described, and describe is basically a very handy function, very useful function that gives you a brief summary of the statistic of your data per column. So it's basically compute the mean, max, median, and some other statistic about your data and print them out in a nice table, such that by looking at this table you can get some insight about statistic of your model. Note that if you have some rows or column in strings or they are non-numerical value, then applying the replace the NaN value by averaging or drop them, sometimes you might get confused. So make sure that you have a good knowledge about the columns, the type of data in each column. So this data set we read is again uploaded on Blackboard. It's called Titanic data. These data are taken from the Kaggle competition. Kaggle competition is an institute. It's run some running machine learning competition with some very good awards. Usually around 20 to 30,000 people are taking part in these competitions, and they're very competitive to get the top ranks. This was one of the Kaggle competition data sets. You can go to the website of Kaggle. If I'm not mistaken, it's like called Kaggle. If you type the Kaggle .com, it will just take you to that competition websites, and they're currently running some data science problem. If you're interested, you can participate in one of them. I know one of them by a pharmaceutical company has an award of $100,000 for the first winner. Anyway, so this data is from Titanic passengers, the gender, age, type of tickets they buy, the fare, which harbor they embark on the ship, and whether they survive or not. So a very nice data set to work, contain both numerical value and also non-numerical value. They also contains categorical data and also non-categorical data. Anyway, so if you want to apply in here, we first read this one, and also in place we apply the drop NA. We apply the drop NA. If you want to apply the or drop the missing value on column, you can just set the access to 1 and then in here show the 5 values. So this shows that if there's any column for which you have missing value. So I believe there is no, if there's any difference between these two data frame, then that shows the column which is dropped. As I said, sometimes you can define a threshold in drop NA. Say if the number of missing value in a row or column is more than a threshold, then drop that row. This is used for some data sets for which we have some, they're very valuable and we don't want to drop when the number of missing value is smaller than a threshold. The second types of technique for dealing with missing value is called imputation. And then imputation, as I said, we usually replace the missing value by mean of a column or row. We use often mean, but you can use also median or other statistic. So how to use that for this data set? Let's say I wanted to replace all missing value in the column titled as age by the mean. So how am I going to do it? So I have this data frame. I get the column labeled as age. Then for this column, I apply the method called fill none available. How to fill it? The missing value should be replaced by this value. What is this value? This value is the mean of this column. How to get the mean of this column? There is a method called mean, which compute the mean of this value. So that's, and then there is print out the first 5 rows. So you can, in here you can use median function, which is defined for the column of a data frame. So as I said, when you are reading a file into pandas, it will be loaded into a data frame. And data frame is a data structure or an object which comes with a number of functions. And these functions are very useful and handy. And then you can do lots of processing, lots of analysis on your data in place on the data frame. If you have a good knowledge about these functions, you can take the mean, median, standard deviation, or many other calculate many other statistical values for your data. So for the sake of simplicity, let's say create a data frame. We call it DF. This data frame is basically, you can specify the column name. So this data frame contains a NumPy array, which is 4 by 2 NumPy array. These are the values for each row. And then you can also specify the column titles, 1 and 2. And then when you read and print out this data frame, you get this. So assume that you have a file, and then when you read this file will be loaded to a data frame, looks like this. In here you have 3 missing value. The first missing value is on the second column on first row, and then for the third row we see that both values are missing. For instance, if you are now wanted to apply the data, this function data, it's what we can do, we can drop the third row. But if the data is still valuable and we don't want to do that, we can compute the mean of the first column and then mean of the second column and replace by the mean. So it's very easy to apply the fill-in function, fill none value, by using the mean. So for these statistics, you can apply the function sum. This function sum compute the sum of the columns. It's smart; it will ignore the NaN value, and also you can compute the mean by using df. This is an object, call the function or method mean within this object, and this function is mean with some input parameters or arguments. For instance, I wanted to take the mean column-wise, so I set the axis to column, and then I wanted to skip the NaN values. This is important because when you wanted to compute the mean, if you haven't taken care of the missing value and you wanted to compute the mean, if you don't specify, then the function will throw an error saying, I cannot compute value for mean, or the mean is NaN. When it says the mean is NaN, that means because there is a NaN in this mean, this column, and you didn't take care of that, then the function compute the mean as NaN, right? But you can say ignore that. But if you already took care of this missing value, then the function mean will compute the mean without any trouble. So here is a list of different methods for a data frame. They're very useful and handy and save your time instead of doing the processing later on. You can compute lots of statistics from your data frame. We highly use this sum function, mean, variance, and also count. Count is a very handy function, in particular when you're dealing with the natural language processing projects. So we can also find the mean. I already talked about description. You can run the above cell replacing by this function and do a practice by yourself and see the results. If you're more interested, there are tons of resources on web, and also you can take a look at the book Doing Data Science with Python, which is uploaded on Blackboard. So these are all function for a method. It's worth to also do a flashback on some statistical measurements, namely mean, median, mode, and their differences. We should make sure that we know what is the difference between mean, median, and mode of a distribution. So simply when you want to compute a sample mean is we add up the values and divide by the number of values. If you want to compute the median, we sort the data. The middle point of this data is median. If the number of samples is odd, then the middle point. If the number of samples is an even number, then what do? We take the two middle point, sum them, and divide it by 2. That would be the median value. The mode is the number in our data set which has the largest frequency. That's called the mode of our distribution. So a distribution might have, all these values might be the same, might be different. For instance, if you have a Gaussian distribution, in Gaussian distribution, mean, median, and mode are the same. But if you have a distribution looks like this, then mean and median and mode are different. So you should know, have a good intuition about the difference between these statistics. So where you want to drop out the data, where do you use the median? When you wanted to replace the value by mean or median? We use median is very robust against outliers, so sometimes it's recommended to use median instead of mean. Also, using read CSV, you can read very huge files. There is the amendment in here using just splitting the data into different chunk size and then read each chunk size. So this function has these feature and attributes that you can specify to read the files to different chunk size. So by specifying the chunk size, you split the function to different chunk size, and then you run an iterator, and then you go through each chunk and read it to a data frame, and then you can work out through this data frame. This is extremely important for today's data science problem because we have dealing with the huge files. In particular, if you're applying the deep learning and you want to train a neural network, usually we use a technique called batch training. In batch training, we split the data to different sizes, and then we apply the optimization method, which is basically a stochastic gradient descent on each batch. So how to specify the number of the chunk size or batch is not related to this topic. We will talk later about that. But the idea here, you basically specify a pointer to the memory location of different its chunk, and then you run an iterator, and this iterator will go and read the data from that part. Um, Another important topic when you're dealing with the data frame is, and also when you read the data now, you want to get a sense about the data, is using pivot tables. I highly recommend you to visit this website by Chris Moffett, where I get these slides also from there. So pivot tabling is basically provide a summary of our data. So sometimes we are interested to get a summary for a column and row. We wanted to summarize one column, how many items we have this column. We want to summarize a column for items. So pivot tabling is a very powerful method, save time and also programming space to provide a very good visualization from our data, and then somehow you don't need to do even further processing. By doing pivot tabling, have a summary from your table, you already can get a sense of what the next step looks like. So here is the data set. It's from some data. I also uploaded this data on the data folder on Blackboard, so you can read this data. These data are some numbers from a sale of computers by different companies and different salesperson. Either they sell or not, how many units, what are the unit name. If you want to find a summary from one column or one row, what basically you do, you can tell, I wanted to do the summary per, let's say, which column. You choose a column and then you get the summary for a column. I'll leave the details to you by running this code and go through these examples to understand how the pivot tabling works. It's not necessarily a pre-processing technique in the data science pipeline, but I found it very useful. Somehow you will be aware of having these tools in pandas that can summarize a table for you. So I'll just jump over these different examples. Another method we also it's worth to be aware of is when you're reading the data sets from different sources, having different column names, they have some shared column names. If you want to merge, you can usually merge the data frame in pandas. You can join them, you can merge them. Sometimes you can only merge them by common columns or not. So in here, this is an example I get from Chris Alman. You can see the further details from this website. So here we have 3 data frames. You can usually concatenate them by using a function called concat from the pandas. If you want to stack them like along the columns, or you want it to horizontally, then also you can use this concat them on different axes. So you can say stack them column wise or row wise. You have these options. There's also a very advanced library. As I don't know if you have already taken a course on databases. Databases are very extremely useful data structure and a way to just save our data. There's a library called SQL Alchemy. This library has a function called create engine that will create databases for you, and then you can read huge data files and then store them in databases. You can read like a file of size 6 or 7 gigabytes and then store them in a SQL file. Be aware of this SQL Alchemy library, which in here I gave you an example how to read CSV file and then store it in a database. So these are not necessarily, as I said, in a pipeline of a data science method, but what is important, the take-home message from today's slides are you should be able to read a file, you should be able to know either if you're using a read CSV, what are the options you have, should you ignore the first column, not, and then how to treat the rows, what are the rows representing by having a description from your data frame to which you upload your file, you read your file, and then the next step is to deal with the missing value, figure out if the missing value are in random or in they have a pattern, how to deal with them, is it safe to drop them or should we replace them by mean or median or other techniques. Highly recommended to use mean and median. Should we replace by the column mean or row mean? This is all depends on your data and what you want to do with your data and what the data represent. And then after you do this processing, the data are already ready. There are two steps left. One is taking how to deal with outliers and how to specify them and how to deal with them. Should we replace them? Should we drop them? That's another steps in the pre-processing, which we'll talk in next video. And then the last part is to do some visualization on your data to get a sense before you feed the data to the pipeline of machine learning algorithm you have, which you want to do prediction, analysis, comparison, or you want to find the significant values in your data sets or whatever technique you wanted to use. So we will follow this topic on data pre-processing in next video. I wish you all a good or night, and then I'll see you soon in next video.